We come to another subtopic under the standard form and indices. This is laws of indices. These are the laws that guide how initial expressions are carried out. Okay, now you can see that the first law here is called the addition law. It says that if you have the same base, this is a, this is a, if a raised to the power of m is times a raised to the power of n, all you need to do is to pick one of the a and then you add the power as m plus n. That's what happens here. Now, if it is the same thing but you have division here, a raised to the power of m divided by a raised to the power of n, what you do, you pick one of the a and you subtract the powers m minus n. That's subtraction law. But if you have in brackets a raised to the power of m and after the bracket you have n, all you need to do is that this m will times this n here. That's law of multiplication. But for the zero law, in indices, anything raised to the power of 0 is 1, always, no matter what it is. Anything raised to the power of 0 is 1 in indices. While for the negative law, if there's a negative power, let's say a raised to the power of negative n, this negative will become 1 over this n will now come close to this as you have here. Now let's look at a few examples we have here. First one is this. Let's look at the solution here. Solution. You have p raised to the power from 2 times p raised to the power of 5 times p raised to the power of minus 3. You can see that this is an expression of indices, and to solve this we're going to use the addition law because this one has times. So whenever you have something like this, you have this time, this time, this. All you need to do, since the p are the same, just pick one of the p. What you do, just pick one of the p and then you add the powers. That's 2 plus 5 plus this one already has minus, that's bracket m. Now plus times minus will always give you minus, so you say p equals to 2 plus 5 minus 3. Therefore 2 plus 5 is 7. Then if you minus 3, I think what you have is 4. So the answer is p raised to the power 4. You come to the second one, which is x to the power 3 divided by x raised to the power minus 7. You can see that this one is division here. You can see division, that's in subtraction law. What do? You minus the powers. Therefore, this is going to be x raised to the power 3 minus brackets. There's already minus 7 here. So x raised to the power of 3 minus times minus will give you plus. That's plus 7. So you have 3 plus 7 will give you 10. I'm sure you're aware with how to multiply signs, that minus times minus always gives you plus, but minus times plus will give you minus. Then we go to the next one. We have 2 raised to the power of 2 times a, rather, raised to the power of 2 bracket 4. So what will happen? This 2 is a different entity, while this one is a different entity. So it will be, let's say there's an invisible 1 here on top of this. So this will be 2 raised to the power 4 times a. This 2 will times this. That's 2 times 4. So you have 2 raised to the power 4 should give you, that's 2 times 2 times 2 times 2 into 4 places. 2 times 2 is 4 times 2 8. So this will be 16a. 2 times this 4 is 8. So that's that. Then go to the last one, which is number 4. 3 over 4 raised to the power of minus 2. This minus here, to take it off, it has to be inverse of this. What's the meaning of inverse? Inverse means that this 4 will go up, this 3 will come down because of this minus. That's when this minus will go out. For this minus to go out, 4 will go up, 3 will come down. So this is going to be 4 over 3 bracket raised to the power of what? 2. Then you continue with this 4 raised to the power 2 here up over 3 raised to the power 2 here down. So 4 raised to the power 2 is what? 4 times 4, I think is 16. Then 3 raised to the power 2, that is 3 times 3 is 9. So that's basically the basic laws of indices. You can practice some other examples and questions from your textbook.